Hello, welcome to the online lecture of Physics 103. In this video, I'm going to talk about friction force. Suppose we have two objects and there is a relative motion between them. Okay, then a force comes into play between the two surfaces, like here. Okay, if you try to push this object on the surface of this object, let's say this is A, this is B. If you push B on the surface of A, then there is a opposing force that comes into play between the surfaces. That force is called friction force. Okay, so in that sense, friction force is called opposing force. Okay, it's always opposite to the applied force. If you apply the force in this way, this is applied force Fa, then your frictional force will be this way, Ff. Okay, on the other hand, if you apply the force from the other side, rather, let's say if you apply the force from this side, then frictional force will be this, the other way around. Okay, this is always opposite to the applied force. All right, let's take a look at this example here. You have an object here which is resting on the flat surface. Okay, or I'll call it level surface here. Then how many forces are there? So definitely there is a force of gravity which is acting down. We can call it negative direction. And this guy is not being pulled by gravity, meaning there must be some forces acting opposite to gravity. And that force is called normal force. Okay, this is plus, this is minus, right? And if some force is being applied to this object, to this direction, let's say plus direction, then there must be a force of friction in the opposite direction, because friction has always opposing nature. Okay, opposite to the applied force. Okay, so now in this case, what happens is this guy does not move in the vertical direction, right? This is moving in the on the xy, left right, or in the along the x-axis, I would say. Okay, if this is y, this is x, this object is moving in the x direction, so it means it is not moving in the y direction. Why is not moving? Because the two forces are equal and opposite, right? So normal force is equal to the force of gravity. So in such a level surface, normal force is equal to the force of gravity, right? All right, so there are two kinds of friction. One is static friction, the other one is kinetic friction. When two surfaces are not sliding across one another, the friction is called static friction. Okay, so here what is happening is you are pulling this object. So this is the object here. You are applying force here. Okay, but this guy is not moving. Why is that? Because whatever force you have applied, let's say you have uh, 2 Newton force, and this guy is not moving because this is very heavy enough and the surface is rough, such that friction is, you know, big, right? So even though 2 Newton force does not pull this guy, meaning why is not this guy moved? Because the force of applied force is equal to the friction force. Okay, they balance each other. That's why net force is 0. Okay, so meaning F and Fs, static friction, right? It's not moving, so that's 0, meaning F is plus direction and friction Fs is negative direction. So this is plus, this is minus, and the net force is 0. That's why this guy is not moving. So if you increase the force here, let's say if you increase your force to 3 Newton here, right? What happens is still this guy does not move, meaning there is a friction now equal to 3 Newton now. Okay, so this plus, this is minus. Okay, so friction is equal to the applied force again. So see, the friction force is self-adjusting to the applied force. Okay, but it does not do that all the time. So at certain point, meaning when the applied force is large enough, then the friction force is not exactly same as the applied force. Okay, so at some point when applied force is just equal to the friction force, what happens is this guy start to move. Okay, so in that case, the friction force is the maximum friction. When the object is not moving, in that case, the friction involved is static friction, and that static friction can be 0 to all the way to Fs max. Okay, so in this case, we had friction force equals 2 Newton because we had applied force equals 2 Newton. The guy is not moving, the object is not moving, means one of them is plus, the other one is minus, net 0. Here we had 3 Newton, the opposing force is negative 3 Newton. Here, let's say at the 4 Newton applied force, I have also the 4 Newton of friction force. But in this case, they are just, they are that equal to each other, but still the force is 0, right? The total force is 0 here. But still, in that case, now this guy begins to move with constant velocity. Okay, right at this point, the object starts to move with constant velocity. Okay, so that impend, so when it's about to move, right? When the object is about to move, in that case, friction force is maximum. That's called Fs max. Okay, so static friction varies from 0 to Fs max. All right. So now I know the direction of the static friction, right? Now, what is the magnitude of static friction? How do you find the magnitude of static friction? Okay. So as we said, the static friction can have value from 0 to Fs max. Okay. So what is the relationship? How do you find the Fs max? I don't have any relation for Fs. I have the relation for Fs max, maximum friction. So how do you find the maximum static friction? Maximum static friction is equal to mu s times Fn. So what is your mu s? This mu s is called coefficient of static friction. Okay, so this is a dimensionless quantity. Dimensionless quantity, and Fn is the normal force. So if you remember from previous slide, if the object is sliding on the level surface like this, okay, this is sliding on the level surface, then what is the normal force? Normal force Fn equals to the force of gravity. So this is force of gravity down, normal force is up. So somehow the friction, this force here, Fs, okay, somehow this Fs is related to this Fn, okay? So how? By this relation. Okay, this is the relation for Fs max. Okay, so frictional maximum friction though. Okay, Fs max. Okay, so Fs max is equal to mu s f. So all right, now, so as we said earlier, the friction force goes on increasing, right? And at some point the object starts moving, right? Once it starts moving, in that case, the frictional force is called kinetic friction, okay? And during that motion, the coefficient involved between two surfaces is called coefficient of kinetic friction. No longer that is the coefficient of static friction, that's the coefficient of kinetic friction, okay? Meaning mu s, even though the surface is same, the coefficient at rest is different from coefficient in motion. There are two coefficients here, static and kinetic, okay? So mu s versus mu k. So when the object is moving, in that case, frictional force in motion is given by similar formula as in static case. In static case, we had Fs max equals mu s Fn, but in the case of kinetic, you have mu k Fn. So mu s becomes mu k. Okay, so now we have two relations. One is Fs max equals mu s Fn. The other one is Fk, K for kinetic, equals mu K times Fn. Okay, so we have two coefficient for a particular surface. Okay, so if there is an object moving on the other object, on the surface of other object, then we have two coefficient of friction. One is for the static case, the other one is for kinetic case. Okay, so this Fs has corresponding coefficient mu s, Fs max rather. Okay, so then it has the corresponding coefficient mu k. So mu s and mu k has the following property. Okay, they are always mu s and mu k, they are always greater than 0, but they are always less than 1. That's the property 1. Number 2, mu s is always greater than mu k. Okay, those are the two properties. Now let's take a look at this problem here. Suppose the coefficient of kinetic friction is 0.05. It does not have unit. This is dimensionless quantity. Coefficient of kinetic friction, meaning we have Fk, sorry, mu k. Mu k is given. Mu k is 0.05. Remember, it has to be more than 0 and less than 1. So here it is 0.05, less than 1, which makes sense. So total mass is 40 kg. What is the kinetic friction force? So what is the formula? Formula is Fk equals mu k Fn, right? So I memorize this formula uh, like fun, okay? Fun. So this looks like mu, right? F equals n. So friction is fun. Friction is fun. That's how I memorize this formula. So if you have 40 kg of object here, this is, let's say this is 40 kg, right? What is the weight? 40 times 9.8 is the weight, right? So that 40 times 9.8 is the downward force. And what is the upward force? Upward force is equal to the downward force, because this guy is not moving in the vertical direction. That's why they are opposite but equal. So then what is your Fn then? Fn is exactly this, but in opposite direction, right? So Fn is mu k is 0.05. What is your Fn? Fn is 40 times 9.8. And if you do that, if you do the calculation, you get 20 Newton. So now what is the direction of this force? Since this guy is moving to the right, the friction is always opposite, which is to the left. Okay, so it is always opposing force. Okay, let's do a couple of problems involving friction, then we are done with this chapter. Okay, so a rightward force is applied to a 5 kilogram object to move it across a rough surface with a rightward acceleration of this. So 2 meter per second per second. So we can write this, you can condense this as this 2 meter per second squared. The coefficient of friction between the object and the surface is 0.1. Use the diagram to determine the gravitational force, normal force, applied force, frictional force, and net force. So this is the diagram. So this mu is 0.1, mu k is 0.1. So why did I not say mu s? Because the object is moving, right? So that's why this is mu k. And acceleration is 2 meter per second square. And the mass is 5 kilogram. Okay. Let's figure out, first of all, let's figure out the gravity, right? Yeah, gravity. So how do you find the gravity? Gravity is obviously m times g, right? Mass, what is the mass of the object? 5 kilogram. And the gravity is 9.8. Acceleration due to gravity is 9.8 meter per second squared. So which is, how much is it? 49 Newton, right? So number 2, let's figure out the normal force. Since the surface is labeled here, so normal force is equal to gravity. So that's very easy. Fn equals Simply you can write this value 49 Newton. Number 3, let's figure out the force of friction. Okay, frictional force. Frictional force Fk equals mu k times Fn. So mu k is 0.1, right? Mu k 0.1 times Fn, you already have it here, 49. So if you multiply them together, you get 4.9 Newton. Now, number 4, you have to find the net force, right? You are supposed to find net force according to Newton's second law. Net force is F equals ma. So m is 5, a is 2. So net force is 10 meter per second square. Now, number 5, you need to find the applied force. So to find the applied force, let's use the definition of net force. Definition of net force is F1 plus F2 plus dot dot dot. In our case, how many forces are there? We have just in the XY direction, we have 2 forces. So you just type F1 and F2. F1 is, by the way, F1 is applied force, FA, right? And F2 is friction, right? F friction. So net force, you already have net force. This is net force. From number 4, you have 10 is the left hand side. Then what is your F1? F1 is applied force. Applied force is unknown, Fa, plus friction force is in the opposite direction, right? If Fa is plus, friction is minus. That's why if Fa is plus, friction is minus. And how much is it? FF is here, right? This is the friction, 4.9. So what is your Fa then? Fa equals 10 plus 4.9, which is equal to 14.9 Newton. Okay, let's do one more problem, then I'm done with this chapter. Okay, so a 5 kg object is sliding to the right and encountering a friction force that slows it down. The coefficient of friction mu between the object and the surface is 0.1. Determine the force of gravity, normal force, force of friction, the net force, and the acceleration. It's very similar to previous problem, but here the 5 kg object slides to the right, and while doing so, it encounters a friction. Okay, so sliding, right? When it says sliding, it means it's moving with constant velocity. Okay, sliding, moving, slides, moves, that kind of thing, meaning it's the constant velocity. Okay, it is moving with constant velocity and it encounters a friction right here. Okay, all right. So now let's figure out the force of gravity. What is the force of gravity? Force of gravity is F gravity equals m times acceleration due to gravity. M is 5, acceleration due to gravity is 9.8, which is, if you multiply them together, you get 49 Newton. Number 2, let's figure out the normal force. Since the surface is level, again, as in previous example, normal force is equal to force of gravity in the case of level surface, which is exactly 49 Newton. And number 3, let's figure out the friction, right? Again, the friction is the kinetic friction, right? This is the sliding object. So mu k times Fn. Mu k is given, which is 0.1 right here. This is mu k. Then Fn is here, 49. If you multiply them together, you get 4.9 Newton. Now, number 4, let's figure out the net force. Net force is, what is the net force? F applied plus F friction, right? F applied is Fa to the plus direction. F friction is the F in the negative direction. So then what is the applied force? Since this is moving with constant velocity meaning acceleration is d minus b0 over t. Constant meaning this guy is 0. That's why acceleration is 0. And since acceleration is 0, force is 0. This is 0 minus Ff. The friction force is this Fk. You can write Fk also if you want. Then this is 4.9. If you do that, negative 4.9 Newton. Okay. So meaning there is no applied force. That's why your net force is simply the friction force. That's why this negative sign telling you. Okay. This is friction force is opposing. That's what the meaning of negative sign here. All right. Number 5, now you have to do the acceleration. As you know, acceleration according to Newton's second law is summation F over M. Summation F is this guy here, negative 4.9 over M is 5. If you divide that out, then you get 0.98 meter per second squared. Okay, this negative sign of the acceleration tells me that the object is slowing down. Okay, slows it. Okay, that's the meaning. With this, I want to conclude this lecture. Thank you.